Hello guys, this is Paul McWhorter with TopTechBoy.com, and we're here today with episode number 44 in our incredible new tutorial series where you're unleashing the power of your Raspberry Pi Pico W. What I will need you to do is pour yourself a nice tall glass of ice cold coffee. That would be straight up black coffee poured over ice. No sugar, no sweeteners, none needed. And as you're pouring your coffee, as always, I want to give a shout out to our friends over at Sunfounder. Sunfounder is actually sponsoring this most excellent series of video lessons. And in this class, we will be using the Kepler kit for Raspberry Pi Pico W. Now, most of you guys probably already have your gear, but if you don't, look down in the description. There is a link over to Amazon. You can hop on over there and pick up your gear. And believe me, your life and my life are going to be a whole lot easier if we are working on identical hardware. But enough of this shameless self-promotion. Let's talk about what I am going to teach you today. And what I'm going to do is I'm going to give you my solution to the homework assignment that I gave you in lesson number 43. But I must ask, how many of you guys were successful with the homework? If you were successful, leave a comment down below. I am legend. Double chest bump. And if you were not successful, leave a comment down below. I folded up like a cheap Walmart lawn chair. Now, what was the assignment? The assignment was to find an orientation or condition or circumstances under which you could observe zero-G measurements on all three axes on the MPU6050, where the X reads 0, the Y reads 0, and the Z reads 0 all at the same time. And so that is what I am going to show you today. Well, to do that, I need to kind of help you guys get caught up that might just be joining us right now. So I'm going to go ahead. I'm going to get out of your way. I'm going to come over here. And to kind of catch up with where we are, you will need to go to the most excellent www.toptechboy.com. Once you're there, you need to use this happy little search icon, and you need to search on something like schematic for tilt meter using the MPU6050. When you come down, you will find this. You see that it's really pretty easy to hook up the MPU6050. We haven't turned on the OLED 1305 yet, or is it 1305 or 1306. I don't remember exactly what that thing is called, but our little OLED. And what you can do is you can hook this up really quick. Just simply the MPU6050. We have the VCC going to 3.3 volts. We have ground going to ground, and then we have the SDA. We have the SDA pin hooked up over here to GPIO pin 16, and we have SCL on the MPU6050. We have it connected to, we have the SCL connected to GPIO pin 17. And so you can kind of get that hooked up pretty quickly. And then similarly, we have this OLED in here because we're going to be using it in future lessons. We have ground to ground, we have power to power, and on that one we have SCL hooked up to GPIO pin 3, and then we have SDA, we have SCL connected to GPIO pin 3, and then we have SDA connected to GPIO pin 2. And so hopefully that makes sense. You can get it hooked up. Also, when you go there, we have a little bit of code that helps us get going on this. And so rather than developing this from scratch, let's go ahead and grab that code that kind of gets us started so that we can move right along down the road on this. So now we're going to come over to Thonny. We're going to paste that little code snippet in. That was an unexpected result. Let me try that again. I must not have copied it. So let's come back over here, and we're going to come here, and I am going to copy that code. And now I'm going to come over here, and I am going to paste that code. Man, that is just not copying for me for some reason. Let me try it one more time. I've got something old on my clipboard, and that seems to be what it is getting. So I'm just going to try it the old-fashioned way of getting it like that. Right mouse click, copy. And now we are going to come back over here to Thani. Come back over here to Thani. And now I'm going to get rid of all of that. Okay, get rid of all that, and now Control V, boom, now I have it. So this measures acceleration in the X direction and Y direction. Let's do that just to make sure the universe is in the proper working order. And look at that. Yeah, let's see, I'm measuring, move that around a little bit. Yeah, I'm measuring 0G in the X-axis and 0G in the Y-axis, as we would expect. And so let me stop that. We also are going to want to do the Z acceleration. And so let's grab this bit of code, okay? And now we're going to go like this, and I'm going to say that that is going to be the Z acceleration is MPU.accel.what? .z. So now we should have all three, and then we also should print that out. So here in our print statement, I'm going to give it the tag z in a string. So I'll say z colon space, and then in that string, and then what do I want to put there? Z acceleration, like that. And then what do I want to do? I want to give it the tag g. Like that. Okay, so it makes sense as we're printing it. Now this time what we should be doing is we should be measuring X, Y, and Z, and we should be plotting it out. X, Y, and Z, and in fact there it is, indeed we have it. And look at that. So I am measuring, let's see, I might need to pull this up a little bit. I want you to really see what I'm doing here. So let me just do a little bit of Windows management here to make sure you're seeing everything that you need to see. Okay, and then I'm going to close this assistant. Okay, so look at this. What is just absolutely beautiful? What is absolutely beautiful? I also need to go over here to this shot, I think. Okay, now we have everything that we need. We got a live shot of the Raspberry Pi Pico W with the MPU6050 on there. We've got that as a live shot. And then you are also seeing the live data coming off of it. So what was your assignment? To measure 0G in the X-axis and the Y-axis and the Z-axis all at the same time. Well, what's really great here, my X and my Y are reading 0, but my Z is reading 1G. Well, what I can do is if I tilt it, then that Z-axis, if I tilt it, then that Z-axis accelerometer, if I tilt it, that Z-axis accelerometer will not see that gravity vector. So if I come here and I tilt it like this, what happens? The good news is the Z went to 0. The good news is the Y is still 0, but what's the bad news? Now the X is reading 1. So what if I come up here like this? Well, the good news is the Z is reading 0. The good news is the X is reading 0. The bad news is the Y is reading -1. So did you guys play around with this, and did you find any condition or orientation where you could read 0 on all three axes? Well, you can see that kind of like no matter what I do, there's always going to be one that doesn't meet that condition. There's always going to be at least one or others that don't meet that condition. So what I probably need to do is I probably need to come over here and play around with the code just a little bit more, because this assignment turns out to be a little bit more tricky than what we thought. As I spin this around in every imaginable orientation, I never seem to get to a point that all of them are 0. So one thing is I want to make sure that I don't miss it. If I get it, I want to make sure that I don't miss it. And so I'm going to look really carefully for that. Okay, I'm going to look really carefully for that. So what I'm going to do is I think that I'm going to do a while Z acceleration is less than or equal to 0.9. So I want to see if something is happening in Z where like the Z is starting to go towards 0G. So that would be like if it's less than 0.9, something is happening in Z. And you'll see later why I'm doing that. Okay, so I'm gonna start it like that. And then in this loop, when something's happening with Z, I'm gonna make these 3 measurements again. Okay, I'm gonna make these 3 measurements again. Okay. And so all these need to be tabbed over once. Okay, so I've got this special loop inside the loop where I'm going to be doing this special measurement all 3 times. And if I measure it, I'm going to want to print it. Okay, if I measure it, I'm going to want to print it in here so that we can see it on the serial monitor or see it on the shell down there. Okay, and on the plotter, that looks good. So now I'm going to want to paste. And so now I'm printing it in here. That looks good. Now I want to know, did I go inside this loop? And if I go inside this loop, I'm going to set the flag equal to 1 to say that I went into the loop. And then up here, if I haven't been into the loop yet, I'm going to say flag equals 0. So if it's sitting with flag equals 0, I never got into the special condition. But if flag equal 1, that means I've been in there. Well, if I ever get in there, then what I'm going to want to do is I am going to want to, when I come out, if flag equal 1, meaning that I went into that special condition, then what I'm going to do is just do a time.sleep of 15 seconds. So if I'm able to achieve 0G, I want to make sure that I stop and I capture it so I can look at it, because if the 0G just flies by, I wouldn't even see it, right? Because that plotter continues to plot. The plotter visualizer here in Thonny, it might just go by without me seeing it. So I want to make sure it's hard enough to get it. If I get it, I want to make sure that I see it, okay? And then that looks good. Now what we also want to do is we want to like put in here a time.sleep of, let's say, 0.01, so we're not trying to run this too quickly. I should probably do this up here too. Just say time.sleep of 0.01. Sometimes these things you're communicating, if you're hammering them too hard, you could cause a problem. Okay, so now let's see, is there anything else I need to do? No, I just want to see now. So what is this going to do? If it sees a z acceleration less than 0.9, then it's going to take the data as long as you're in that special condition, and then when that special condition isn't there anymore, it's going to pause, and that way you can see the data. Does that make sense? I hope it does. So let's come over here and let's go ahead and run this and just see if it runs. Okay. Good news is it's running and nothing particularly special is happening. Why is nothing particularly special happening? Because the Z is measuring 1G, right? And the X and Y are reading 0G, and so there's no really special condition that is happening there. The thing is just kind of rolling on through. Okay, so now what I'm going to do is I'm going to see if I can create that special condition. Let's see if we can get 0G. Let's see if we can get 0G. So I'm going to come over here and I'm going to pick this up and I'm going to drop it. And now look at that. I need to get out of your way here, but look at this. Okay, what happened? I got to get out of your way further. Look at that. I had a little bit of 0G on X, Y, and Z, and then when the thing hit, you got a rapid deceleration. Okay, so let's see if we can try that again. Let's see if I pick it up a little bit higher, okay, and drop it, and look, I got 0G on all 3 axes from the time that I let go of it until the time that it hit the ground. Now you see a little bit of noise there. That's probably just this cable impacting it a little bit, but let's try it again. Let's see that if I get it up here, and that time I think I almost tilted it. I think that's what froze it. Let's give it the 10 seconds, okay? And it'll start up live again, and then I'll drop it. Okay, there it goes, and now drop, and boom, look at that. X, Y, and Z are all 0G. Then when I hit the ground, I experience a rapid deceleration. Okay, so you guys might be saying that I cheated, but I said find an orientation or a condition where everything is 0. So now why is it 0 in that set of conditions? Well, it is 0 for this reason. And in fact, you know, that is bugging me a little bit. I want to make sure that that is completely flat. I'm going to try it one more time and just show you all 3 of them at 0. Okay. That one I didn't get a clean drop. A little bit of a perfectionist here, and then we'll talk a little bit about the physics of what's going on. We'll give it a second here. Okay, that's pretty good. 0G all the way across. 0G all the way across the board. Okay, now, why is it that it's 0G when I let it go? Well, that's because it is in free fall. It is responding to that acceleration of gravity vector. It's responding, instead of that gravity vector pulling the z-axis proof mass down, it's responding by accelerating the whole board down. And when it accelerates the whole board down, the proof mass does not see the acceleration. So when I'm sitting here still, the gravitational vector is pulling the z-axis proof mass down. Once I start falling, then it is pulling the whole board down, and that z-axis proof mass does not see the gravitational vector. Why? It is in free fall. It is what we would call 0G. Now, another way, if you wanted this thing to read 0G in all three axes, what is another thing that you could do? Well, you could go on the International Space Station, because they are in 0G. Why are they in 0G? Not because they are so far away from the Earth they don't see its gravity. No. The space shuttle and the International Space Station, they see the acceleration of gravity. Well, why are they in 0G then? Because they are free falling towards the Earth, and then they just kind of fall over the edge and they go into an orbit. Or another way that you could look at it, if you thought of, you had a string on the ball, you had a string on a ball and you went like this, and the ball sort of stays in the air. Why is that? Because the centrifugal force goes this way, and then the string is pulling it back this way. The string would be kind of like gravity, and when you go like this, they're perfectly balanced. Okay, so in the condition of 0G, all of our accelerometers read 0. How do we get into the condition of 0G? We get into the condition of 0G by being in free fall. Okay, by being in free fall. And while we are in free fall, we can measure that condition of 0G. Now, what is the acceleration of gravity? Well, the acceleration of gravity, if we want to express it as a force, it is 1G. But what is the actual acceleration that a body falling towards the Earth in free fall experiences? Well, in meters, it's 9.8 meters per second. Okay, if you want to do it in feet, it is 32 feet per second. So if something dropped in free fall for 1 second, what would its velocity be when it hit the ground? It would be 32 feet per second times 1 second that it was experiencing that acceleration, and therefore when it hit the ground, it would be moving at a velocity of 32 feet per second, because the other per second multiplied out. What if it was in free fall for 2 seconds? Well, it would be 32 times 2 would be 64 feet per second is how fast it's going when it hits the ground. Okay, now I have another little assignment for you. Okay, I have another little assignment for you. And guys, I know some of you guys, when I give you a homework, what you do is you go out to Google and you look for a solution, like give me MicroPython code that will calculate blah, blah, blah. Try to figure it out yourself, because I've taught you the math. I've taught you how the accelerometer worked. I taught you about these things, and I want you to really see it. So what I want you to do is, and for this first assignment, you can just do it on your desk and see how accurate you can get. And what I want you to do is, I want you to make a little device that will show what height you were at when you dropped it. Okay, so like if I come here like this and I drop it, it should read out that I dropped it from 2 inches. Or if I come up here if I come up here and drop it, it should show that it was dropped from 4 inches or 8 inches or a foot. Okay, so I want you to create a method of determining vertical displacement by taking this and dropping it. Now, for this assignment, it's okay to just print the result in Thonny, and then you're going to be dropping it between maybe 1/4 of an inch, 1/2 an inch, and 12 inches, and see how accurate you can do it. Okay, now you're going to have to figure out, what could you measure right now? What could you measure right now? Let me wait a second and just show you with what I've done so far. What could you determine? Okay, you could determine, I got a really ugly release on that one, so that one did not look very good. But what you could see is, you could see how long you were in free fall, how long you had 0 G's before you hit the ground. Okay, you could see how long you were in the air. So what the trick for you to do is how to calculate how far it fell based on how long it was in the air, which is how long you were at 0 G's. Now, I'm going to challenge you, try to do this without going up and looking at the solution, just looking up the solution, right? Try to kind of figure it out yourself. What have I told you? I've told you that the acceleration of gravity is 9.8 meters per second, or it is 32 feet per second. Okay, that's a pretty big hint. And then what is the velocity as it's falling? The velocity, it's going faster and faster and faster. The velocity is the acceleration times time, and that velocity would be in feet per second or meters per second. And now, what is distance? Distance is velocity times time. But be careful, because the velocity is changing. Okay. All right, guys, let me know. You know, what we were doing is, right, what were we doing? What were we doing? We were right in the middle of creating a tilt meter, and we kind of got to the point that we could measure negative tilt, negative roll, and positive roll. And all of a sudden, I got distracted on this other thing of finding 0 G. And now, in the midst of our tilt business, now we are coming in and trying to find a drop meter, something that will tell a vertical distance based on dropping something. That actually, I think, could be kind of a useful little device if we make it work. And so that is your homework for next week, is to show that you can measure vertical displacement by measuring how long that you have been at 0 G's. Okay, guys, I hope you're having as much fun taking these lessons as I am making them. I hope you don't get mad at me for taking this little diversion, but I just thought it's really interesting math and really interesting physics. And I think we'll do 2 lessons on this, and then we'll go back and we'll start working on our tilt meter again. But maybe we'll have something that will measure pitch, roll, and vertical displacement all with one simple little program. So hopefully you guys don't get mad. Hey, I want to give a shout out to you guys who are helping me out over at Patreon. I've let you guys know that YouTube is doing things different these days. They're valuing very short, silly, many times lewd little clips, and they're really not interested in long, knowledge-rich educational videos like I'm doing. So I have really been hurt by YouTube and the advertising that they put on this channel. So right now, it is you guys that are helping me out over at Patreon that are keeping me in the game. And so I want to thank you for that. You can also help me by leaving a thumbs up on this video if you liked it. You can also help by leaving a comment down below. And then also subscribe to the channel. When you do, ring that bell. Okay? And most importantly, share this video with other people, because the world needs more people doing coding and fewer people sitting around watching silly cat videos. Paul McWhorter with TopTechBoy.com. I will talk to you guys later.